Alright, welcome to ElmLive for November 25th, 2016. So this month I have been streaming every day for Codevember, doing a creative code project every day. So today we're going to be continuing something that we started yesterday. Yesterday we got this little checkerboard set up where we can click and move pieces around. And what I wanted to work towards was setting this up so that when we move pieces, it actually moves parts of the board around with us. So that's the idea of what I wanted to work towards. And we only got the initial board set up yesterday. So let's continue from there. All right. So let's take a quick look at our code again. So we have our main.elm. Our model has a board in it, which is defined in a separate module that we wrote. We have a selected tile, and then we have a click tile message. And let's pull up the debugger also here. So let's see, scrolling, let me bump up the font size here if I can. Okay, so going back to the beginning, we click the first tile, it selects the tile, then we click somewhere else, it moves the tile. I guess it's not particularly complicated. Okay, our update function, if there is a selected tile, then we tell the board to make a move from the initial position to the second clicked position. And if there is no currently selected tile, then we select that tile. We also wrote our view function that knows how to render different kinds of tiles, which are either empty or occupied with a piece. And then the rest of the code is in our board module, where we have different kinds of pieces, and we have different kinds of tiles, and then the board itself has a number of columns and rows, and a dictionary which contains the tile at each position. Then we have a function that creates the initial board. And then we have some helper functions, and then our make move function here, which takes two positions and finds a tile. Oh yeah, here's basically the main code for moving a piece. If the from tile is occupied and the to tile is empty, then we just move the piece from one tile to the other. All right. So, my original idea was that each of these pieces would have kind of a different shape attached to them, like a Tetris piece shape. And then whenever you move the piece, the tiles adjacent to it would move on the board along with it. So let's try that out. So I guess what we're eventually going to need is, for each piece, we're going to have like a Tetris shape associated with it. And then, in addition to that, we'll use that to know which pieces to move. So I guess let's try setting that up. So a piece now is going to belong to a player. And in either case, let's see. I guess we want to change a piece here. So we'll change this to be called player. And then we'll have a new type called piece. which is going to, let's see. I guess we can actually keep the current piece we have. We'll have a basic piece, which will have a player. And actually, I'm realizing the ownership of the piece doesn't really matter in here. So I think what we can do is change this to be a tuple. So we'll have the owner here of the piece and then the piece itself. And we'll have a basic piece, which is what we currently have. We can just move it. And then we'll also have the, not sure what to call it. Maybe we can call it a terraforming piece, because it's going to move the board along with it as it moves. And if we have one of those, we're going to need a set of coordinates that are going to change with it. So let's have that be a set of int ints, which will be relative to where the piece is at. Let's see, we're going to need to import set. Okay. So, right. So then each of these pieces are going to be basic pieces. Basic piece. And then our main is going to need to be updated. Okay. So here we get the player and the piece. And then we're going to case on the player to get the color. And we also need to export the player type and a few other things. The piece type, okay, we're exposing that. The player type we also need to expose. All right. Okay, so that's refactored. What we also need is, I guess we want to render the special pieces in some particular way. So for the moment, let's do this. We're going to do case piece of, and if it's the basic piece, then we'll just do nothing for the moment. And if it's our terraforming piece, then let's draw another circle just temporarily, and I want to do something a little fancier here in a bit. But let's just fill this with, let's see, maybe like a purple. Let's add an E. And we don't need a stroke on that. Okay. All right, and then let's have our player one pieces, or let's just make one of these a special piece for the moment. If row equals 2 and column equals 2, then we will make our special piece. And this will be set.empty for the moment. Okay, and there we can see it highlighted in pink. And let's see. I guess I'd like to choose from among like a set of standard pieces. So let's define, let's see, let's call it a T-shape. That is a set of int, and I think we have set from list. So that'll include the relative to the piece, the space itself. It's going to have the piece to the right, or the space, the tile to the right, and the tile above, and the tile below. Okay. So now we want to change what happens when we move this piece around. And actually what we need is I think we want to change how our board is modeled as well. Because what I'd like to do is, when I move this piece, then the surrounding tiles are going to move along with it, and they're going to stack over the tiles that exist there on the board already. So to do that, we are going to need to change the tiles themselves to not just have a single color, but to, I guess, contain a non-empty list of colors. And actually, if the list is empty, then that just means there's no tile there at all. So I guess we're really just changing this into a list of colors. And this will be the same thing here. And then the doesn't exist is going away and will be replaced just by an empty tile with no list of colors on it. So if we make that change to our model, okay, then here, that'll change. And the same thing here, these both become empty. And the same thing here. All right. And, great. So when we create these initial tiles, they'll all have a single color underneath them. Okay. So now we need to fix up our main.elm. And where's the error? Right, so this goes away, and actually, we can keep this case. If it's empty with an empty list, we'll show nothing in that area, or in that part of the screen. And here, this should fail, yeah, because colors. Okay, so in this case, we're going to have the top color followed by hidden colors underneath. So we're not going to render those at the moment. We'll just always show the top color. Okay, cool. So that refactoring worked. That was fairly straightforward. So now, I think everything's set up. The rendering was basically just done quite easily for us as we refactored that. So our final step is to change our makeMove function. And this is going to get more complicated because basically now we want to, whenever we move a piece, if it's one of these terraforming pieces, we're going to move all the tiles affected by that. So I think we need to make an extra function to handle just that part of it, and then we can chain it in here as appropriate. So let's call this terraform board. This is going to take a position, a from position, and a to position, and it's also going to take our set of points that are relative to the from position. Then we'll also take a board and give a new board back. Okay, so what we want to do is, I think, look at each one of these locations in the set, and for each one of those, we want to move the tile color that's at that location and place it in another location. So I think we're going to need another helper function, or at least this will be a little more straightforward. It'll be terraform tile, which is going to take a position and another position and move just the tile along. So we'll have from to, and we're going to destructure our board because we made a private type constructor. So here we get just the record. And let's see, we want to return a new board. Actually, and we can simplify this a little bit by just making this be the dictionary of position to tile. So this will just be the tiles. So we are going to, I guess we need to check the tile at the from position to pull the color out. So let's do that. So we'll do a case of dict.get at the from location from the tiles. And if we get an empty tile or an occupied tile, okay, so I guess we need a let statement, because there are a couple cases in here. So this will be the from color, and I guess we'll get the whole thing. So if we have an empty tile with colors, then we will return the colors. And if we have an occupied tile, we don't care about the piece in that case, then we'll return the colors, and otherwise we will return an empty list. And I'm already thinking it might be a good refactoring to do if we separate the tiles themselves from the pieces and store those in different dictionaries. I think it'll probably make things work out a bit simpler. But I think I'm going to continue with this first, and once we have it working, we can try doing that refactor and see if it simplifies things. So let's see, we get our from colors, then we can case on that, and if we get an empty list, then we're done, there's nothing to move. And if we don't have an empty list, if we have the moving color followed by the remaining colors, then we're going to take tiles, and ooh, yeah, this is going to be tricky to do if we don't pull this out and do a separate dictionary. Okay, let's put this on hold for a minute and do this refactoring. Let's make sure we're in a compiling state. And I probably should be committing at this point, but I'm just going to try plowing ahead. Okay, so here's what I want to change. The tiles themselves. A tile is simply going to be a tile with a list of colors. And then the pieces will store in a separate dictionary, which will take a position and give back a tuple of player, comma, piece. Okay, so let's see what kind of errors we have here. Okay, so this function, we're going to need to call this map tiles. And these both are now called tile. And we're going to change this map function to be called map tiles. And this is now called tile as well. And we have a bunch of other empty, which are all going to be called tile. And this is also called tile. Okay, what's next? Then here's where we create a bunch of pieces. So what's the best way to do this? Really, we just want to insert into the dictionary a bunch. Okay, so we'll need to figure out a nicer way to add our starting tiles. Hey, Albernacker. Well, it's sort of a checkers game. I'm working on the part right now where the board, like the tiles on the board, move around as you move the pieces. So it's not going to be checkers for long. So, alright. So right now we're refactoring to split the tiles and the pieces information into separate dictionaries. So that the information is separate and it'll be easier to transform. So here in our make move, okay. So I guess what we want to check is the from piece. And in the make move, actually the tile itself is not going to matter. Because we're really just moving pieces at the moment. So this is going to change to be pieces, from to, and then from tile. This is now going to be the from piece, or I guess it's just the piece to move. And this is going to come from the pieces. And we aren't going to need a with default for that. So then if we have a just piece, and then I guess we're also going to check if dict.member, I think, is the function to check if it exists there, to board.pieces. And that'll be false. Okay, and then we don't need this. And then we also don't need to check for any of this. Like, the only reason we had this case was to move the color from tile to tile, which we don't need to do now that the tile colors are no longer part of the same data structure that has the piece in it. So actually all we're doing is saying dict.remove the from, and then dict.insert in the to location of the piece. And let's see. The other thing we want to do is make sure that we don't actually move if the space is already occupied. So I guess we can just do that in an if statement down here. So we'll say if there's already a piece at that location. So I guess we can call that isValidMove. And it's going to be the opposite of if there's a piece there. And I guess there also has to be a piece. I see. There also has to be a piece available here. Okay. So let's see. Kind of jumping all around here at the moment. So we're going to say if we have a piece and it's invalid, so if we get a just piece and the move is valid, then we are going to return a board which has the pieces changed, where we're removing the piece from the from location and we're inserting that piece in the to location. And if we get anything else, we're just going to return the board that was passed into us. And then this all goes away. And this is called isValidMove. Okay, I think that's right. And what else is going on in here? We need to initialize our pieces. And we'll start with an empty set for the moment. We're going to have to come back and fill that in just a sec, but let's get main to compile first. Okay. And then render tile. We'll need to take a piece also. And we will case with the tile and the piece. And there shouldn't ever be a piece on an empty tile. I guess there could be. I guess we need to render these two things separately. So we will have an svg.group. In here we'll have our render. Well, let's see. I guess we need to do a case in here for the moment. We are going to render our piece. So that's that, and these are now called board.tile. And that's that, and then we're also going to have a case statement on the piece. And it's actually player comma piece. And I guess that's going to be in a maybe. Okay, so if we have a just of a player piece, then we are going to draw this. I guess this also goes in a group. And let's see, and this all goes away. And let's see, what's messed up here? Okay, so that goes away. And, okay. I guess that's working. Then down here, we have added an argument to render tile. And we're using this view helper function here. So we need to add this argument here. And that means when we pass that into the render tile function, I guess then this also needs to be the piece, which is going to come from dict at column comma row in board.pieces. All right. So what's going on here? And then we don't have a nothing case if there's no piece, and that's fine. That's just going to be an empty DOM node. And this one can do the same thing. We don't need an extra group element in there. Okay, so our board still works. What we haven't ported over yet is this code, which was inserting the initial pieces into the board. So I guess we can do that here, where we will, I guess, fold over a range. So we'll take list.foldL, and we're going to get an index and the pieces, and then we're going to take pieces and insert into it. Dict.insert at I comma, I guess 0 comma I, a new piece which will be player 1 comma basic piece, and we'll fold over an empty dictionary, and the list we'll use is list.range from 1 to 8. Okay, so that should add some pieces in there. And unfortunately that is not working. But let's check our debugger. So we have pieces, and it has a bunch of values. Oh, right. We're using one indexed rows and columns. Okay, so there's our black pieces. So this should actually be 1 plus imod2, and we can actually flip that around, I guess 2 minus imod2. Okay, and then we'll also at the same time insert our player 2 pieces into column 8. Okay, there we go. So this code here is replacing all of this code that we had down here. Okay. And, oh, what is this? Oh yeah, this is the code that we were starting to write. Okay, so we just finished a refactoring where we used to have a single dictionary that stored a data type that had information both about the color of the board and the piece that potentially occupied that space at any moment. And we just did a refactoring where we split that out into 2 separate dictionaries so that we can track them independently. The goal for that being that now when we write these terraforming functions that modify the board, they should be a lot more straightforward to write. And in fact, here we were writing this case statement to pull out the colors. Now we just directly have those colors as part of the tile. So we don't need a case statement here anymore, and we're also not going to need to have a case statement to like merge the colors back in depending on what kind of tile it is. So that's all going to be great. So here, the from colors is simply tile that, and this goes away. So this is, I guess we are still destructuring this, but I think that's all right. I guess we could write this helper function, pull top color. So this will take a tile, and it'll give back a maybe of a color and a new tile. So given a tile, this will give us the top color and then a tile that will remain with that color removed. So let's write this function, and I think it'll be useful for us. So we will destructure this, and we'll say case colors of, and if it's an empty list, then we're returning nothing. And otherwise, we have top color and the remaining ones, in which case we'll return just the top color and a new tile with the remaining colors. So in this case, let's see. So here we're going to have the moving color and the remaining tile is going to equal, and we'll find the tile at the from location from our tiles, and then we're going to maybe dot and then with this pull top color function, which also returns a maybe, and our dictionary.get also can return a maybe. So using and then, we can chain those together. So if there's a value from this, then it'll call this next function, and if there isn't, it'll skip it and just return nothing altogether. So I guess this really gives us a maybe rather than this thing we can destructure right away. So I guess what we're doing is taking this and we're going to case on that. And if we get a just, then we're going to be getting these two things. And if we get a nothing, then we're just returning the same tiles that were passed in. Okay, and if we get this, then we're going to take the tiles and we're going to insert into the from location whatever remains, and we're also going to insert into the to location, I guess we want to stack this color into it. So I guess for that we are going to need another helper function. So this will be push top color, I guess. And that is going to take the to location and the color that's moving. And then this all is junk. And we need to write this push top color function. So this is going to take, ultimately it's going to add to a dictionary. And it's also going to take a position, and it's also going to take a color. Let's see, is that right? I guess what I really want is we want to push a color into a tile and get a new tile back. So I guess to use that properly, is there like a dict.update function? Let's check the docs for that. Update takes a key and then a function from a maybe value to a maybe value. Okay, yes. So we want to update the item at the to location, and this is the value. We want to do a value, pipe it to maybe.withDefault of a tile with no colors in it. And then pipe that to our push top color with the moving color. Okay, that's a bit more code down here, but I think this function is more reusable. So this is the new color. And this is the tile, and all we're going to do is return tile with new color tacked on to the beginning of it. And then we don't even need a let down here, and I spelled position wrong. Alright, and what's messed up here? The function update is expecting the second argument to be this kind of function, but it doesn't return a maybe. Okay. So we need to put that in a maybe at the end. Okay. So now we have our terraform tile function, which takes a position and applies a function on it, or applies this transformation of checking if there's a color to pull, and if there is, it moves it, and if there isn't, it doesn't. Okay, cool. So now we can write our terraform board, which given a set of locations relative to this initial position, it's going to move all the colors to their target location. And I guess the order matters here, because we really want to do these all at once. But for example, if we move a color from one tile to another, and then we need to move the color from that tile as well, then things can get tricky. Interesting. I think we might have to handle this a bit more, in a bit more sophisticated way. Because I think we're going to need to read out the list of all of the colors we want to push on first. And then once we have that, then we can apply all of those pushes. Because if we just won't move one at a time, then depending on the order that we move things in, we might read the wrong value. Okay, so we might not actually end up using this function, but we will still need these for sure. Okay, so relative locations, or these are the froms. This is the from center, and this is the to center. And this is the board. So I guess I'm thinking about this in terms of like processing the data. So if essentially this is kind of the list of updates we need to make, or the transformations we need to make. So if we can take this and kind of translate it into a more explicit list of commands, then I think that'll be the simplest way to think about this. So if we start with a set of integers, integer relative locations, what we can do is apply the from center and the to center to both of these and end up with a set of tuples, which is like a from and a to, both of which are points or positions. Then we can read all of the current colors out of the board, and I guess transform the board as well. So I guess this would be like lifting the top color out of all of the places that are moving, and I guess we'll also update the board at that point. So then we'd end up with a set that has the from location. It'll have the new tile that's going to be sitting there. Is that what we want? I guess not. What we want is, now we're going to take our board and have our new board well, let's see. So from this, we can get out of it two things. The set of positions, the from position, well, we're definitely going to have the maybe color, along with the to location, where it's going to be merged into. And I guess at this point we should also have our new board, which contains all of the top colors lifted out of all of the from locations. Okay, I think that'll work out. And then once we have that, then we actually don't need this position anymore. We've already applied it. I guess we could do this in smaller steps. So here we're going to have the from position, the new tile that's going to go there, the color that's coming out, and the target location. Then we can take that and produce a board and a set of just the target things. And then we'll finally end up with just a board. Okay, I think that'll work. So we start with our relative locations. Then with the centers, we can figure out the actual from and to locations. Then we go through each of the from locations and figure out what that tile will change into, and then what color is coming out. Then we can apply this first part of the changes and like pull the colors out of all the tiles that are in the from set. And then we end up with just a list of colors that need to be pushed onto each of these positions, and then we can push all of those. Okay, I think that'll work and will be algorithmically correct. So let's see if we can write this then. So we have this initially, it's just this relative froms. So we want to create this. And for the moment, I'll just put some placeholder here. So what do we want to call this? Movement. I guess movements. this is a set of positions and positions. And this is going to equal, essentially we're just going to map over this. So is there a set dot map? And we're going to get a relative position, and we're going to return a tuple, and I think we'll want a helper function called add, which just takes a position and gives back a new position. This is xy, x1, y1 equals x plus x1, y plus y1. So we're just going to add the relative to the from center, and then we'll add the relative to the to center. Alright, so where's my syntax error here? Oh, I forgot my backslash in the lambda. Okay, and for the moment I'm just going to return board. And I forgot to pass the set that we're mapping over. Okay, so that works out. Then what's next? So next we want to go through each one of these and produce the result of this pull top color off. And that also gives back a maybe. Okay. So when we look at set, so we were using map there. Is there a version that lets us pass a function that has a maybe in it? Looks like no. Okay, because we're going to need a way to handle the maybes in here. I guess we already are accounting for that because it'll be a maybe color coming off of this. And I guess I'm realizing we can put the maybe inside of this tuple because we can always get a tile back. We will just have the tile itself. And in here, yeah, then the just is going there. Okay. So we'll get our maybe color and our remaining tile for each one of these. And this function I think we're not going to end up using, but if we need it later, we can pull it back and fix it up. Okay. And I guess, let's see, I'm realizing we can build this all in one step here. So if we have this will look ugly for a second. If we have a let block in here, from position equals this, and then we also have the moving color and the remaining tile equals pull top color from the from position. What does that need? That takes a tile, doesn't it? So then we need to get the tile Whoops, I'm losing my cursor position in here. So this is going to take the board.tiles, dict.get, the from position out of there, and we'll have maybe with default of an empty tile, and then we'll pull the top color and get this tuple out. And then in here, we will just stick that in the remaining tile and then the moving color. Oh, this is called tile, not empty. And now our type annotation is wrong. We've actually built this all in one go, I thought. Let's see, the function map is expecting the first argument to take a int. Let's see, and everything else matches up. Oh, is position a float? Where did we define that? No, position is a tuple of int, int. So those are the same, position, tile, maybe color. I'm not sure why it thinks those are different. I guess I maybe, let's see, let's read through this. So from position, the relative froms is a set of ints, or int pairs. That should be the same as a position. So then rel should be a position. Add takes two positions and returns a position. We are getting from our dictionary of board.tiles, and board.tiles is a dictionary of position to tile. That all seems right. Let's see. If I take that out, it seems fine with the arguments if I take that out. Oh, am I missing a comma or something here? From position, no, pull top color. Huh. No, that's having the same problem. So we had it just working fine with that tuple. Okay. So that works fine. If we have a maybe color in here also, this should give us a type error. It does. And if we put a nothing here, then it still doesn't like that. I am not understanding why it doesn't like having a third argument or a third item in this tuple. And it seems like the type checker is messing up in that case. Let's see, if we take this out, put this in there, and then take this type annotation off, Yeah, it's saying these types don't match, but they look the same to me. Let's see, is it something with this let statement? If we add this in here, that still doesn't work. Let's try pulling this up to an extra function. Okay, and then we pull that off. Yeah, well, I am stuck with that. I feel like it should be something simple. Or that I must be missing something simple. It's just late at night tonight. First argument of map is causing a mismatch. Yeah, those types definitely look the same to me. From position, we are adding a relative type. Let's try this. If we have column and row, and pass that in, nope, that still doesn't work. If we just put 0, 0 in here, nope, that doesn't type check either. Alright, well, I am totally stuck for the moment. It is too late on a Friday night, so I am going to end this here for the night, and hopefully after a good night's sleep I will understand what's going wrong with this. So thanks for tuning in tonight, and let's see, if I get this figured out tomorrow, I'll probably wrap up this board game project tomorrow, and if not, we'll get back to it another time and do something else for Codevember tomorrow. But have a great night, and I will see you next time.